Welcome to Wetlands Part 3. If you haven't watched Parts 1 and 2 yet, please do so before you watch this one. So overview, I'm putting types of wetlands into our field trip recording. So that's just going to be extra fun information for you. You don't have to know it for the class, but I'll give you that content anyway, but it'll be in a field trip format. So this presentation will just be about wetland trends. Big concepts wise, in this part of the lecture, we're going to cover that many people didn't realize until relatively recently that wetlands provided this disproportionate amount of ecosystem services. They were thought to be kind of just a garbage, useless land that you could be paid to convert into other uses. So we'll look at kind of how that tended to work out. This is a pretty cool site you can go to. I didn't include it, all the pictures in here, but you can go to that link and then kind of travel around the world and look at the different types of wetlands that you have in different areas. Unfortunately, only half of the US has been mapped, and we just barely didn't make the cutoff there. So if we kind of zoom in on what California looks like here. So we can see that there's a large amount of wetlands in the Central Valley. A lot of those wetlands have been repurposed for agricultural purposes, and a lot of the wetlands that should have and used to exist there no longer do. So that whole stretch of the Central Valley would have just been like one giant floodplain with a lot of other different types of wetlands speckled in between there. We can look at Louisiana and Mississippi and kind of look at their very dense cluster of wetlands. And that's because that's where the Mississippi Delta is. So this huge river drains out into the Gulf of Mexico right there, and you get a really diverse set of wetland ecosystems. So a really cool place to visit, but definitely a place that is under threat from all of the causes, but a major one is sea level rise, particularly for the diversity of coastal wetlands that they have. So wetland trends, over half of global wetland area has been lost. In some areas like California, that number is more like 90%. So remaining wetlands only cover about 9% of global land area, but much of those wetlands are degraded. So they might be somewhat functional, but they don't have perhaps the total function that they would have if they hadn't have been changed, like our wetlands across the street from CR. We have this strip of coastal wetland, but then we have farms and freeway kind of blocking it in, so it doesn't have the ability to migrate around as maybe it would have been able to before, as rivers changed course and as kind of sediments deposited by the ocean changed where they were located. It's now very stuck in place, and so that can change the functionality of a wetland. So thinking about those across the street wetlands, the entirety of Humboldt Bay used to be one huge wetland. When I did research for our class talking about trying to find examples for how to do good field journaling, I looked up if there were any field journals that had been recorded in the Berkeley archives for Humboldt Bay region, and there was one, and he's talking about being out in freshwater and all of the salicornia, which is pickleweed, that was just everywhere out in freshwater. And so that area now is a little town. You still have a lot of freshwater wetlands there, but the ocean would have come all the way up to there. That was a saltwater to brackish water wetland, which is pretty cool. So around 1900, a system of dikes and levees, so those are large earthworks that are going to prevent ocean water from coming in and river water from going out, were installed in the Salmon Creek watershed, which is the one that's right across the street from our school. But there's, I think 5 other rivers that drain into the bay. Maybe it's 5 total. And so you can see the picture on the left. It shows the historic water channels that would have moved through that area. And the picture in the middle there, well, I guess on the right, shows the channels as they are now. So it's been highly restricted to one major channel, and the rest of the area around that was developed into agricultural land. So they're currently in the process of restoring it, kind of providing a more sinuous channel so that the water runs through slower, and so there's more variety of habitat, more structural heterogeneity to that water source. but it's still, very much in progress. So that is a cool thing that you can see on our field trip across the street from CR. So previously, any conversion of wetlands used to be seen as a positive change, and most of that conversion would go to agriculture. So there were these swampy areas that you couldn't build anything on. They weren't growing food that you could actively eat, or that people weren't familiar with eating. The wetlands in our local area were heavily used by the indigenous people. Wiyot, I believe, means river. And so the people moving into this area didn't see those as useful lands, but the people who are indigenous to the areas with a lot of wetlands did. So just a difference in knowledge of those ecosystems. So history of conversion of wetlands. Basically, all wetlands were converted into agricultural lands or other purposes up until the late 1970s. That's when the first legal protections for wetlands were established. So that was by Jimmy Carter in 1977. And so the bill was just to avoid impacts on wetlands wherever possible. But that's pretty loose language. What determines how important the thing that you need to build is. So then 10 years later, during the Bush administration, there was the no net loss of wetlands policy. And so this was a great policy, but it wasn't very well enforced. And there's a lot of reasons for that, but this is still happening now, where no net loss means that if you're going to build somewhere and remove wetlands, then you need to make new wetlands somewhere else. So there's problems with that in that not all areas are suited to be wetlands. The other problem is that often the funding or the requirement for you to do that is only going to be for like a 5-year span. So you got to build your wetlands and establish them in 5 years and watch over them for that time and try to get any invasive plants over there, fix any of the problems that you have. But after 5 years, you just abandon it. And then there's no one checking to make sure that that's actually a functional wetland anymore. And that's not really a very effective strategy. So in California, the California Environmental Quality Act, which is a really good act, requires that if you are going to remove some amount of wetland, that you need to build 5 times more wetland area than what you converted or impacted, which is really cool because it's not just no net loss, but we're trying to make a gain in the amount of wetlands that we have. But this still totally suffers from the lack of oversight in how those wetlands function later, the lack of accountability on the people who then build those wetlands. So it's not a great system, but it's at least a push in the right direction. So if we're looking at our trends, conversion of wetlands is still happening at a rate of about 1% lost per year globally. So when we're already down so much globally, still losing wetlands every year is a huge concern. And one of the big concerns is that wetlands are our big buffer to climate change. They are going to help us deal with all of the coastal changes that we're going to have particularly. So when we're thinking about how climate change is going to impact us, wetlands will protect us from that. Also, if we're thinking about how climate change is going to impact ecosystems, wetlands are going to be some of the most impacted because they're there on the coast. So even if you do have a coastal wetland, if it isn't one that's functional or doesn't have the ability to move and migrate uphill, like ours, are going to run into 101 and they're not going to have a place to keep transitioning backward as sea level rises. So that's not necessarily a fully functional wetland, and it won't respond to sea level rise in the way that we necessarily want it to. So it's possible that that whole area will just get covered by water and we'll lose that coastal wetland because then we're just into sort of like grassy hill territory. So that's a possibility that we'll lose a lot of wetlands with the kind of current climate change projections. And the other wetlands that we're projected to lose a lot of are our northern latitude peat bogs that are going to get too warm and emit a lot of methane. Okay, so this is an example of a really nice abstract. that you're going to be reading a lot of abstracts as you go through your research. And so I wanted to give you some practice. I'm going to get my pen out of here. I tucked it away to charge. Oh crap. Got it. So I wanted to give you some practice reading an abstract with me. So here is one that is very relevant to what we're talking about today. So as sea levels rise, a resilient coastal wetland can respond in two ways. It can migrate upslope to escape rising water levels, so that's your horizontal solution, or it can trap and accrete sediments to keep pace at the rate of sea level rise, so that's the vertical solution. So you can move inland or you can move upward. The two solutions are not necessarily mutually exclusive. The current practice of removing or breaching dikes and levees to restore historic coastal wetlands allows for both solutions, creating a pathway for landward escape and providing for the reintroduction of sediment-laden waters, be they tidal, riverine, or both, to the restored wetlands. So we'll stop right there and just think about what we just read. So we have these two major ways that wetlands can deal with the changes for climate change. They can move inland or they can move upward by accreting sediment. And so if we remove dikes and levees, that is going to allow sediment-laden waters to make it to those wetlands to deposit that sediment. So we need that to have the vertical solution be possible. So over the past 2 decades, using marker horizons, surface elevation tables, and lead 210 dating, we've measured rates of accretion and elevation change in numerous coastal wetlands of the Salish Sea. So they're looking at how much sediment is building up in these coastal wetlands. From this, we present here 2 lines of evidence that point toward the potential and efficacy of dike removal as a restoration tool in the face of rising seas. First, in relatively unmodified, unlevied natural coastal wetlands, open to the subsidizing energies of tides and sediment-rich river water, we consistently measure rates of sediment accretion equal to or in excess of the current rate of local sea level rise, indicating an adequate sediment supply for marsh maintenance. So if we break down that sentence, in natural wetlands, the accretion of sediment matches sea level rise. Second, our measurements in coastal wetland sites restored by levee breaching reveal high rates of accretion and elevation gain, far exceeding current and predicted rates of sea level rise. So in that situation where we're trying to restore a wetland, we actually get more sediment than we would in a natural system, possibly because it's been built up for so long in these other areas where it's then getting re-added. Adding in that last little bit myself. For example, in a recent restoration site in the Stillaguamish River estuary, we measured a mean rate of elevation gain of 3.1 centimeters per year since the levee was removed in 2012. So we could compare that to sea level rise in that area, but I don't know what that is. In summary, the main active deltaic distributaries of the Salish Sea provide a source of sediments that coastal wetlands, unencumbered by levees and dikes, can and do use to maintain a dynamic equilibrium with sea level rise. So this is a pretty well written abstract, very accessible, especially compared to the ones that you're going to read. But what you want to do as you read these abstracts is break them down into little parts and maybe, make notes on the side to yourself of, so you can make notes to yourself about what the important points of a chunk of that paragraph are. So like in this first spot, important stuff might be 2 ways wetlands escape or just react, right? So you're thinking, what are they trying to tell me in that little bit? And then in this next one, both natural and restored, oh gosh, that's hard to write, wetlands can build vertically. Ooh, this is so tough. So just writing little summaries of the important points to yourself. And if you can't figure out what the important points are, it could be that it's terribly written. So don't just blame yourself. But you can always send an abstract to me and tell me what you think it's trying to say, or highlight a sentence that you're having trouble understanding, and I'll help you through it. So this has been Wetlands.